Who is this?
Uh,
All right. So for the circuit below, this is the problem. I'm going to change it up a little bit, but we'll do something like it. From the circuit below, what is the sequence of output values on consecutive clock pulses starting from Q2, Q1, Q0 equals 0, 0, 0 until reaching 0, 0, 0 again? So I'm going to change this up a little bit just so we don't have exactly the same circuit, but it'll have the same ideas. So I'm going to have that going into there, and instead I will have, so I'm just basically changing the order. Okay, so rather than having, it's the same idea of the circuits, just in a different order.
Okay.
Okay, all right. So I have Q2, Q1, Q0. Now, keep in mind that this order is the reverse order of the way they're written up here. So just be aware of that. So we're going to start with looking just at Q0. So Q0, it always has an input of 1, and its clock is the clock. And so that just means on every clock cycle, it's going to toggle. And to make this slightly different, I'm going to say we're not starting at 0, 0, 0, we're going to start at 1, 1, 1. Okay, so at the first clock cycle, we know Q1 is going to toggle. So it will become 1 goes to 0. And as a matter of fact, Q0 is just going to toggle every time. Okay? Now, the Q1 also has the clock as its input. So it will also toggle every time. So it's Q2 that we have to pay attention to. Now, this is the tricky part. What does a positive edge mean? It's when it went from 0 to 1. Okay, so on this first clock cycle, Q1 is its input. Is it going from 0 to 1? No. So it's going to be 1. On the next clock cycle, is it going from 0 to 1? Yes. So that will make it toggle, and it will be 0. On the next clock cycle, is it going from 0 to 1?
Aren't you done over there now?
Why am I done?
Until reaching 0, 0, 0 again.
Well, I made a different problem, and I haven't reached 0, 0, 0 again.
I'm so blind, sorry.
Yeah, and I haven't reached 0, 0, 0 again.
So it should be 0 again, because it's going from 1 to 0.
That's not a positive edge.
It should still be 0.
No. Oh, it should still be 0, right.
And then now it goes to 1.
Uh-huh.
And it stays at 1.
And it stays at 1.
Then it's done.
No.
Yeah, now it's done. Then it would be done. Yeah. And now what's going to happen if you have, if I had done this differently, is sometimes you can end up with these delays cascading, and so you can have one of these that, like, see how this one had to wait, it was every other clock cycle. If another flip-flop depended on this one, then it would be every 4 clock cycles.
For which one?
Like if I had yet another flip-flop here, and the clock went to that. So let's say this is Q3. So it's gonna be looking, and it has
Oh,
one
yeah, it
coming
would be
in.
every 4.
Yeah, it's every 4.
Yeah.
So just kind of keep that in mind too.
Okay.
I got a question.
Yes.
Can you go up a little bit? That's all. My question is, but it didn't reach 0, 0, 0 again, did it? Because,
It didn't, but I made a different problem. I started at 111.
oh, so you're.
I
yeah,
wanted to, my problem was I start at 111, and when do I
Yeah.
reach 111 again?
Until you reach 1, okay.
That's
Yeah,
what it's-
yeah, so I made a different problem.
Oh, okay, let me check something real quick. Did, oh, but, so you're, so you start